Physics Part 22. The basic method of measuring a time interval is with a stop clock or a stopwatch. In each case, the instrument is started and stopped by pressing a lever or a button and reset by pressing another control. You should familiarize yourselves the way of operating the instrument before you start at a timing experiment in earnest. Remember that the reaction time of the experimenter, a few tenths of a second, is likely to be much greater than the uncertainty of the instrument itself. If you do not reduce the effect of the reaction time, an unacceptable systematic error may be built into the experiment. As explained in section 2.2, one way of reducing the effect of reaction time is to time enough events, for example, the swings of the pendulum, to make the time. A good technique is to count the even swings, commencing by counting down to 0 and starting the timer at 0 count. Wherever possible, work with at least 20 seconds worth of events, oscillations, and repeat each set of the timings 3 times. Sometimes when carrying out experiments on damped oscillation, you will have to be satisfied with fewer swings, but try not to go below intervals of 10 seconds. The stop clock or stopwatch. First of all, we have got the stop clock, and thereafter we'll talk about stopwatch. Stop clock, a mechanical spring-powered stop clock, will have an analog display. That is a hand or hands which move round a dial. Such an instrument is likely to read the nearest 1/5 of a second. The other one is a stopwatch or a digital timer. This instrument has a digital display. It is based on the oscillations of the quartz crystal. The readout will probably be to the nearest 1/100th of a second. The readout will probably be to the nearest of 1/100th of a second. In addition to the start, stop, and reset controls. Digital stopwatches often have a lap facility, which allows one reading to be held in the display while the watch is still running. Because of this complexity, it is vital that you know the functions of all the controls. Your own wristwatch may well have a built-in stopwatch, which may be just as precise as the watches available in the laboratory. However, the start and stop controls on the wrist stopwatches are sometimes rather small, and it is important that you should not fumble a start or stop signal. I beg your pardon, please. Choice of method. Often students are attracted to a digital stopwatch because it reads to 1/100th of a second. However, in all experiments in which the start and stop signals are applied manually, such accuracy is unnecessary and inappropriate. The reaction time of the experimenter, which is likely to be a few tenths of a second, will cancel out the accuracy of the watch. It would be misleading and bad practice to enter times such as 21.112 seconds in a table of result if the systematic error due to the reaction time had not been fully accounted for. Thus, if you are doing an experiment on the timing of the oscillation and there are no digital timers available, you will be at no disadvantage if you have to use an analog stop clock.